So today we will be taking thesaurus based algorithms, and the thesaurus or dictionary based algorithms actually again require the inventory, but in that inventory the labels are not required. So the inventory contains the sense of the words. These are the sense. So bank 1 and bank 2 are different senses of the words, and they have their gloss and examples present here. So we have a gloss that is explaining the sense of bank 1 of. So for sense 1 of bank, it is a financial institution that accepts deposits and channels the money into lending activities. The sense 2 is explained by the gloss as sloping land, especially the slope behind the body of water. And we have this examples present. The word bank is utilized in the sentence. So the bank holds the mortgage of my home. Similarly, he sat on the bank of the river. So these are the usage of the words or usage of the senses of the word into a sentence. So these could be taken up as an input for the thesaurus based algorithm, and the most popular algorithm is the simplified Lesk algorithm. So what does this simplified Lesk algorithm do is that it takes a test sentence. It takes a test sentence and then it sees in this inventory that's it. Let's take one test sentence. So it takes this test sentence. This is the test sentence. So in which this test sentence, bank is the ambiguous word. Okay, we need to identify in this test sentence whether the bank belongs to sense 1 or sense 2. So we need to identify to which sense does this bank word belong in the test sentence. So the test sentence is the bank can guarantee deposits will eventually cover future tuition costs because it invests in adjustable rate mortgage securities. Now how does the algorithm proceeds? So the algorithm actually finds in the inventory the different senses of banks. Suppose these two senses of banks are found in the inventory, and these are the textual data that is available with these two separate senses. So what it will do is that it will pick up all the senses one by one and it will find the matches between the two texts. So this is the text of test case, text of test sem, and this is the text of corpus or text of sense 1. So it will do is that it will do some kind of matching between the two, right, and it will generate a score. So this performs the matching. It performs matching in between the text and inventory sense text, and then computes a score. So it does this for all of the senses present in the inventory, right? So it will generate a score of for sense 1 of bank, and it will generate a score of sense 2 of bank. Whichever sense is having a higher score, that is the predicted sense, right? So how does it match? It takes all the words one by one and then find which of these words are present in these glosses and examples, right? So it will take this word can is a stop word, and it will check for the guarantee. Guarantee is not present, so it is not present. Will is a stop word. Eventually is also maybe treated as stop word, and cover is also not present in sense 1, but we see that deposits is present in sense 1, right? So if we take a simple count as a score, count sense 1, so the count is 1 for deposits, we get for the deposits, these two are matching. And then we see all for all different words, we again see that another count is there for mortgage. So in this way we are getting these counts. So this count becomes 2, and count for sense 2 is 0, as none of the words from this text match in these two in the second sense of this gloss and examples of bank 2, right? So the predicted sense is the sense 1. Okay, so let's see the algorithm. So algorithm takes input the word, so this word is the ambiguous word, ambiguous word, so like bank, and this sentence is the test sentence in which word appears, right? So bank word is appearing in this sentence, so we assign a variable best sentence as the most frequent sense of the word, so, and we assign another variable, that is the maximum overlap, to 0. So the best sense is assigned as the most frequent sense of the word. So initially what it is done is that we see that which is the most frequent sense, like we also have the frequency in this inventory, like it appears, suppose in the overall corpus it has appeared in, say suppose 58 times, and this second one has appeared in 29 times, right? So we do have the frequency as well, right? So now the context is another variable or another data structure that we can use, is the set of words in the sentence. So we take out these set of words from the context of the word. So we take all these, the context of the words. We can do this in a fixed window, we may not do it. So this can be done for a fixed window also. Okay, and second thing is that we can also remove the stop words, remove the stop words, and other irrelevant word. So we consider only those words that have some kind of information in it. So we define again for each sense in the senses of word. So this loop will execute for the number of senses times. So there are 2 senses, this loop will go for 2 senses. So for each sense it will calculate the signature and it will calculate the overlap. So what is the signature? Signature is the set of words in the gloss and examples of the sense. Okay, so the signature of bank for sense 1 is the set of words in this. Okay, and the set of words in the overlap is overlap is actually the count. So we have a function that is called as compute overlap. So this computes and returns a score for signature and context. So we have this context as a set of words, in sentence, test sentence, and this is the set of words in gloss and examples. So we compare these two set of words. We have a kind of list which is having words. This is the list here. So we have this list, we have this deposits, and we have this mortgage. We have these two words in common, the deposits and the mortgage, and then this is also having the deposits and mortgage. So this list is of sense 1. So in first round this list will be calculated. So using these two, some kind of score will be generated. Using these two, some score will be generated. These two will be generating a score. Right. Similarly, we can have the same thing for the sense 2 as well. Sense 2 is having this signature. So in this signature there is no overlap or no common words between the test. So this is also be given as an input to this score, and we will be getting two scores each for sense 1 and sense 2. Whichever is higher, we compare it with the maximum overlap, and if it is a maximum overlap, then we assign that particular sense with the best sense, right? And at the end we return the best sense. So in this way this simplified LESC algorithm is working. So this simplified LESC algorithm is pretty simple, and it works pretty well. It works very well with the data that can be obtained from the WordNet, and it also works well with the data that is available with the Wikipedia. We can have the Wikipedia articles, and then we can extract the data with respect to the ambiguous words. We can have the examples of the words that are present on Wikipedia, and then we can have their sentences, and then we can manually assign the senses to those different examples or those different senses, right? So this works quite well, and it is treated as a baseline algorithm in the WSD tasks. And we also know that the supervised machine learning algorithms are also working well. So it acts as a baseline. The algorithm that is giving performance below this LESC algorithm is not suitable for word sense disambiguation. So there is another kind of improvement in the LESC algorithm that is called as the corpus LESC, in which we have this IDF weighting. what we do is that we calculate the inverse document frequency in respect of each of these senses, right? So how do we calculate the inverse document frequency? So we calculate the inverse document frequency for each word present in the test sentence. So we have this test sentence, okay, and then we calculate the inverse document frequency of each of these words, and then what we do is that we actually multiply the inverse document frequency with the score, computed score of those words, right? So what we did is that in this case we are actually computing the score for all the words that are present in these in this test sentences, right? And then we get only the positive score for deposit and mortgage, and the rest of the scores are 0. So score is actually the summation of score I, where I is the each word present in the test sentence. So I belongs to all words in test sentence. So what we can do is that we can take the inverse document frequency, or the second thing is that we can just take the inverse document frequency of only those scores that we have in the final score, right? So corresponding to the words that are present in the test sentence, and those give the positive scores, we can calculate the inverse document frequency, which is defined by the log capital N by DFI, where N is the total number of documents and DFI is the number of documents in which the word I is present, right? And then we can calculate this summation of IDF. So this inverse document frequency, and it is multiplied by its corresponding score, compute score, right? So in this way we can do the IDF weighting. So we all know that IDF weighting is also a popular method of weighting in case of term frequency, inverse document frequency, and it actually reduces the common thing between all the documents. So whatever words are common across the documents, so their weights is reduced to near to 0, and the words that are uncommon or the words that discriminate between the different documents, their weight goes high. So that's the purpose of using the IDF weighting, right? So in this way we see that we have two types of algorithms. One is the simplified LEST, and one is the improved version of simplified LEST by applying the IDF weighting. Okay, so